The topic of this video is one-step dimensional analysis problems. So first of all, we're starting with a little bit of a picture riddle, I guess you could call it, and want to start in the upper left here. And there's two examples that are fully done, and I want you to see if you can pick up the pattern. So as you're looking at this, you notice it always starts with something over 1, and then the square shows up here, shows up there, and then it's gone. Circle shows up here, shows up there, and then it's gone. And then I'm left with a triangle. There was never a triangle on the bottom, and so that's what I end up with. Same thing in the next one. I've got a heart here, and then the heart's gone. A cylinder here, cylinder gone. The triangle thing, double triangles there, and it never got crossed out, so that's what I ended up with. So then take a look at the lower right and see if you can predict what symbol would be in the space of the question mark. So we see the pattern again. That symbol shows up on the top and the bottom, and then it goes away. Lightning bolt, top and bottom, goes away. So then the one thing that didn't go away is the star. All right, so down here we ended up with the pentagon in the at the end spot. Smiley face goes away. So down here is going to be the wheel looking thing. Okay, so this pattern is the pattern you're going to keep as we're doing dimensional analysis. Except instead of shapes, you're going to use things like, oh, meter here, centimeter here, and inch here, and end with inch. So we're going to use units instead of shapes. But always remember that pattern. It's the same idea, because when we divide something by itself, we can eliminate it. It's kind of like canceling out in math class when you have like x squared times y over x, and you can see that you have an x on the top and the bottom. You can get rid of the x, you can cancel that out, so it ends up being just xy, because you can divide the x from the top and the bottom. All right, so dimensional analysis is we're going to converting a unit, or it's a way of converting units by the use of conversion factors. So we're going to have different relationships between units and use that in order to set up our math. And then you can easily go through the math once you set everything up. And I feel like it's quite satisfying once you set everything up and you're just knocking it down like it's dominoes. So a couple things you'll need to remember. We set things up always with that same pattern where whatever we have on the top goes in the bottom of the next factor. So it's always going to be, so whatever this starting number unit here, the starting unit goes down there so that they're able to cancel out. And then wherever the numbers end up, if the numbers are on the top, you're going to multiply. And then if the numbers are on the bottom, then you would divide by something that's in the bottom, and then you want to have your answer with the correct units. All right, I'll do this. I'll just do one of these. So we want to start with something that's real simple, that makes sense to you, and you can probably do it without dimensional analysis to kind of really show you what you're doing when you make this conversion. So convert 48 eggs into dozens. Well, whenever I do this in class, students always yell out, oh, that's 4 dozen. All right, but then you want to think about how you got there. The conversion factor you used was that 12 eggs, for every 12 eggs, you have 1 dozen. Then what you did is, I'm going to set it up as dimensional analysis. I started with my 48 eggs, and I'm just going to put that over 1. And then, since I'm trying to end with dozens, so I like to put the beginning unit and the end, so it gets a little bit more clear as to what I'm going to cancel out and what I'm going to end up with. So now I need my 12 eggs and my 1 doesn't. So one of these needs to go on the top of my conversion factor, one on the bottom. Since I'm starting out with eggs, and again, I need to keep that pattern, whatever is here needs to be here. Those two things have to be the same so that I can cancel them out. So then I have 1 dozen on the top. So those cancel out. And then mathematically what I'm doing is I take 48 times 1, and then I'm going to divide it by 12, and that ends up giving me the 4 dozen that we came up with at the very beginning. All right, now we're going to apply it to things that maybe are some new units. So let's start with this one. Convert 1,250 meters into kilometers. I'm starting and recognizing what are my units. And this is a conversion factor that we want you to have memorized. 1,000 meters are equivalent to 1 kilometer. In every 1 kilometer, there's 1,000 meters. Then I'm going to set up my problem. So I always start with the unit that I'm given in the problem. And it is crucial, absolutely crucial, that you put the unit in there. Because again, this whole thing is about units. That's how you know what to do. And then according to this, I only have one conversion factor. So I'm going to leave space for just one line, equals, and I'm ending in kilometers. So I need to get rid of meters and move into kilometers. So since I have meters on the top, I need to have meters on the bottom. And then I'll have kilometers. I'm going to go into kilometers, so that's going to go on the top. Then I take, my conversion factor says that for every 1,000 meters, there is 1 kilometer. So I now have this set up, so I know whether I'm multiplying or dividing by 1,000. So this is going to be 1,250 times 1 divided by 1,000 mathematically. And again, I hope you recognize that, well, that times 1, I don't really need that. Because when you multiply or divide by 1, it ends up to be the same value. So I take 1,250 divided by 1,000 for 1.250 kilometers. Or let me make this actually better for sig figs and actually get rid of that, because that would not be significant. All right, let's go on to the next one. All right, convert 65 inches into centimeters. So I know I'm starting with inches, ending in centimeters. I have one conversion. So I would look up on a conversion sheet how many inches are related to how many centimeters. That wouldn't be something we'd expect you to have memorized. I would find that 1 inch is equal to 2.54 centimeters. All right, then I start setting it up. 65 inches over 1. And again, because there's only one conversion factor I'm going to use, I only need one spot for it, and I'm going to end up with some number in centimeters. All right, again, since inches are here, I need inches on the bottom. And then I'm going into centimeters. So I look at the inch number, and I take the number that's in front of inches in my conversion factor. Same thing with centimeters. All right, so now I know that the inches would be able to cancel out, and I would end with just centimeters. And now I have to look at it mathematically. I would take 65 times 2.54 and then divide that whole thing by 1. And again, I can just ignore the 1. So when I multiply 65 times 2.54, I would get 165.1 centimeters. All right, let's do one more. All right, convert 62.5 meters into nanometers. All right, so I'm going to start by looking at the conversion sheet we give you, and I'm going to write out actually exactly what I see, and then we'll talk about what that means. So on the conversion sheet, if I see nanometers, 1 times 10 to the 6th, it says nano n equals 1 base. All right, so I want to make sure you understand what the base is. So if I look at these two terms, so nano is a metric prefix. It's something I can put in front of one of our base terms to indicate, is it really a small measurement or a big measurement? The base term is the term that shows up in both things. It's a term that the prefix is in front of. So in this case, my base is meter. The base could be liter. It could be gram, it could even be joules or watts or some things that you have not seen yet, but it could be any of those things, and I'm just putting a prefix in front of it. So when I write this, thinking about that, I'm going to write 1 times 10 to the 6 nanometers. Or if I'm familiar with that, remember it says N is the prefix, meters is M. I can write 1 times 10 to the 6 nm. is equal to 1 meter or 1 m. All right, I'm actually going to change where these are. I don't want you to think that we're dividing by anything. So I'm actually just going to put that up there. Yep. All right, now I start my problem. Again, I'm starting with the 62.5 meters over 1. Looks like I have one conversion factor to get me from meters to nanometers. And then my answer will be in nanometers, or nm. So since I'm starting with meters on the top, again, staying with that pattern, meters has to go on the bottom. Nanometers would then go on the top because that's what I'm trying to get into. Then I take the numbers from my conversion factor, 1 meter. For every 1 meter, I have 10. I'm sorry, this should be 9. I've been screwing this up the whole time, sorry. 10 to the 9th nanometers. 6 would be micro. So 1 times 10 to the 9th nanometers. All right, then I can plug that in. And again, now I'm plugging it in scientific notation. And the way I would type in the 1 times 10 to the 9th, depending on which calculator you're using, if you're using a TI-85, you're going to want to look above the comma button for that EE. And what you want to end up is typing in 1 E9. That EE is the calculator's way of saying, oh, I know I'm in scientific notation. I need the base number. I need the exponent. That's all I need. If you're using one of the classroom calculators, it'd be 1 and then E. Actually, I think it actually still is the EE key and then 9. So I plug this in, 62.5 times 1 times EE 10 to the 9. And the calculator, my calculator is actually giving me an answer in scientific notation, which would make sense because it's going to be a really big number. So 6.25 times 10 to the 10th. And there you go. Hopefully that helps.